Recently, my daughter asked me what I did for a living. She knew I was an oceanographer and a professor, but as she put it, you just seem like a guy who answers email all day long. To a large extent, she's right. Email is the main tool I use for communication, coordination, and collaboration. But the research I conduct is hopefully a bit more exciting than that, so I described it to her using a few drawings. We share those drawings and that description with you here, however, with her as the illustrator. Let's start from the top. Our planet is made up of the solid Earth, the ocean, and the atmosphere. Different gases make up our atmosphere, with nitrogen, oxygen, and argon making up about 99.9% of our atmosphere. The remaining 0.1% contains the greenhouse gases. Now, we hear a lot about human emissions of the greenhouse gas carbon dioxide, and that is driving our current global warming. But there are natural processes that can influence greenhouse gas abundances, such as photosynthesis by plants and the decomposition of leaves that fall off a tree. Humans and other animals also emit carbon dioxide when we breathe. There are indeed other greenhouse gases in the atmosphere, and water vapor is a significant natural greenhouse gas. And some of the other greenhouse gases that humans have a significant influence over are methane and nitrous oxide. Seawater in the ocean contains a huge amount of carbon dioxide. Approximately 45 times more is stored in seawater than the atmosphere. And the mud at the bottom of the ocean houses approximately 2,500 times more methane than is in the atmosphere. And scientists like myself wonder if changing temperatures and climate will cause the ocean to release some of these extra gases to the atmosphere. So, one of the things that my group has been focusing on is all of this methane in the seafloor, and if the ocean warming is causing more of it to be released. When it is emitted from the seafloor, we see streams of bubbles of this greenhouse gas seemingly marching toward the atmosphere. However, we don't see a lot of these methane bubbles actually making it directly to the atmosphere. Instead, much of these emitted gases dissolve in seawater, much like sugar dissolves into a hot cup of tea. Once it dissolves, there is what we call a dynamic biofilter, a group of microorganisms that blooms up to eat methane when more enters seawater. We certainly didn't discover these organisms, but we have been able to show that they are capable of eating methane a lot faster than what many people expected. We made these discoveries while working at sea collecting data. Since making measurements at sea is so hard, we design and build a lot of our own equipment we need to make these discoveries. And that equipment and those techniques which we have built helps to determine where the released methane is going, how much and how quickly it is being released from the seafloor, and what the ultimate fate of that methane is. Is it being eaten by microbes or is it being released to the atmosphere? And that is what my group does when we're not on email. Thanks for listening.